Well, hi, good morning, and thank you so much for joining me in my shop here. Look at that, an empty bench. What am I going to put on it? I'm going to put this great big box on it here. Oh my God, I've got another tube tester. Oh no. Yeah, so that's what we're going to do. We're going to look at this tube tester. I don't really know anything about it. I just acquired it. Did not pay much money for it, but I actually paid money for it. And we're going to have a look at it. I don't know how far I'm going to get in this video. I don't know. We will see. Okay, and today is September 21st, 2023. Okay, so this is a Precision Apparatus Company Incorporated Precision Test Equipment. Standard of, you know, it might say excellence there, but it says something else. Standard of, and I can't see. Just one sec here. Got my magnifier in my pocket. Standard of accuracy is what it says there. This is the model 1054, serial number 3108. That must be, it looks like it says 4.8 amps, but I'm sure it's 0.48 amps. I can't imagine it's 4 amps in there. There's the CSA approval number, Canadian Standards Association approval number. Okay. Any other secrets on this? Nope. And underneath, I'm sure it's nothing there. Yeah. Okay, let's look inside. Drum roll. Spider running away there. Look at that thing. Oh my gosh. Now there's a tube tester. Wow, somebody had an eye for design when they came up with this one. So let's see, just look it over very carefully. So you have different sockets up here. You have a line adjust control here. Pretty stiff. We have a very unusual tube socket here. You don't see in many. And I just stuck my finger into a dead spider down there. And we have a set of controls across here. I notice they're labeled A, B, C, D, and E. This lever I just moved says lever return. So I'm going to guess when you have these set and you're all done, rather than zero them, you can do this. Just, yeah, like that. Zero them all. Good guess. This says normal. And then it's W, X, Y, and Z. Well, why would they use letters so late in the alphabet? But they have. I don't see any reason offhand. We're going to study this meter in a minute. It's got an awful lot of stuff on it. So here we have, it says line off, 1.2 and 12 amps. Over here is a white button, different than all the rest, and it says read meter tube test. Oh, this one popped up. This popped up. Line off. I see a couple of these push button caps are missing. The button cap is missing. That won't stop it from working though. And what is this whole panel? It's got numbers 1 to 12. Voltage, resistance, and current. Sounds like meter settings really. 6 volt, 12, 16, 300. So I think, you know, you're going to read voltage on this meter. Now, what are they doing here? Why would you do that? So this must be more like a general piece of test equipment in your shop. Or maybe you're bringing it out to somebody's house to fix their television. And this thing comes out not just as a tube tester, but can supply a few other things. Like for instance, it has a meter here you can utilize. Look at all these inputs for I guess you put meter leads in here. So noise test, conductivity test, 60 microamps. There's a scale up here. There's a 0 to 60 scale. 30, 60, 120. So everything is in sixes here. So 60 microamps. That must be straight onto the meter movement to get that kind of sensitivity. This is 1.2 amps and then 12 amps. External test, 1200 volts. Okay, so I'm not trying to understand it necessarily, just sort of get it in my head what it is. Somewhere there's a well, I've got all these documents to take a look at. Here, what is happening here? These are open holes here. It says DC, AC, there's a plus sign in the middle, and it says 6,000 volts. Uh, 6,000 volts. Really? What are you doing with 6,000 volts? This must be the on-off indicating light, and over here is a neon bulb for shorts. There's a switch here. It says tube, and below it says COND dot, like conductor. What? Conductance. Conductance? Okay, don't know. Here is a series 1054 tube and set tester. Set tube and set tester. Test master. Oh, it's a master. Precision Apparatus Company Incorporated, Elmhurst, New York. Okay, is there anything else to see? Yeah, we're going to look at this meter. Let's see if I can get the camera just in a better position to get a good look at it here. Does that qualify as a good look? Yeah, that's about as close as I'm going to get to it. So first, break weight, replace and good when weak in the middle. That suggests that this is not a transconductance tester, it's a emissions tester, so it's going to measure the amount of current that flows through a tube under the conditions that this operates the tube at. It'll be calibrated. Whoever designed this, the people who designed this, will have calibrated it so that enough conduction in the tube will put the pointer over in the good zone. So it has an ohm meter reading at the top. I don't remember seeing an ohm meter setup. So exactly what we're reading there, I don't know. Below it in red is the AC scale. And right below that is a DC scale. You can see how the lines are just in a little bit of a different position. The key values, like the 5 volts, is you can see that they're offset a little bit. The zeros probably line up, and the end lines up here. Okay, and then we've got these 3 scales, 30, 60, and 120. At the very bottom here, we've got a decibel scale. The 0 is right in here. That's interesting. I didn't see anything either that suggested decibels. That would suggest testing the sound level. I hope I can find a manual for this. That's for sure. 20,000 ohms per volt DC and 1,000 ohms per volt AC. So 20,000 ohms per volt DC. This is a pretty good movement. Fairly sensitive. That doesn't take a lot of current to operate it. Once again, it's probably that 60 microamp setting, or this thing down here. Probably is the amount of current required to push that meter all the way over. Okay, now there's a bunch of papers in the back here. what do we got here? Well, this certainly looks like a circuit diagram. Precision Apparatus, series 1012 and 1015. This is the 1054, many numbers beyond 15. It's got the name of the guy who drew it. Drawn by Kolbach. I think it says Junior. Date 1947, so a couple of years after the war ended. Of course, there was an explosion of this kind of stuff, of this kind of all kinds of consumer electronics. And this isn't consumer electronics, but this will go along with the wave. Noise test. Looking for any notes that might be worth 1 amp fuse, extractor post, attachment plug. It's just a plug. What do you mean attachment plug? Okay, is there some kind of tube in here? N2. Series 1015 incorporates 2 red and 2 black large caps. Caps. They actually wrote caps there instead of, well, I assume, this capacitors. Hey, drafter, how come you don't use the full word? He didn't want the word to leak over here and then make this look ugly, so he used a short form there. Okay, that's what I can get out of that. Maybe, you know what? Maybe the bar of gold that I'm always looking for is going to be in here. This could be it. This could be it. Additional tube test data for use with roll form MRC AGA2, MRC interim supplement, Precision Apparatus Company, postage paid. Of course, when they make these tube testers, as soon as they put them on the market, the tube manufacturers start introducing new tubes. And so they have to update the instructions for it. There's another letter here. Condensed tube testing instructions. Oh. Read the complete instruction manual before attempting to operate this instrument. Use these condensed instructions only as a simplified guide for test of standard type tubes. And hang on to this piece of paper. I think we'd like to try at least one tube in this. Okay, we'll study that. I'll study that. On my coffee break, I will study that. This has got to be a roll. D.L.R. Hale, RR7, Peterborough, Ontario. RR means rural route number 7. That's the postal route that he was on. Postmaster, contents merchandise. This package may be open for inspection. There's the 54. The date on 64. I think that says 64 is the date on it. 6 cents Canadian stamp. So it must be an updated roll, or maybe this is the old roll. This could be the old roll. I don't think I'm going to take it out. I've taken it out. Yeah, that's a roll, all right. It's got some tape on it. So this is the old roll. And we must have the new roll in the machine. Can I get this back in the tube? Yes. Okay, another secret in here. Ooh, there's a big piece of paper here. Back up, everybody. Everybody would be me and a tripod. Oh, wow, what's this? Oh, that's interesting. Average characteristics of receiving radiotrons. Look at this. Radiotron WD11. I have a WD11. Look, see, it's on the top of the list. I have a WD11. Appears to have a burned out filament though. WX12. These are all very old. UX240. These are all old. This is a really old. well, there's old information, but where to get it from? And it's been photocopied, so it wasn't photocopied in 1925. And what do they have in here? They have use. So they describe what it's used for. Detector, amplifier, detector, audio frequency amplifier, power amplifier, full wave rectifier. Interesting, I like this. Base style, height, diameter, voltage supply that you need, dry cell, storage, battery, filament terminal voltages, filament current. That's kind of neat. It's like a quick reference chart for all the popular tubes back in the late 1920s. This would be 1920s. Detection, amplification. There's 2 pages here. Whoop. Oh! What's this now? It's the same thing. It's the same thing. It's got the same ones. WD11. Why would they have the same? Yeah, it's exactly the same. Must be the early days of photocopiers. Didn't know what they were doing. Read-Write Meter Works Model 245, Weston Electric Instrument Corporation Model 555. What's this got to do with anything? Amplification, detection, general. It's the same layout. The tubes here, 01A, 2224, 2640, number 80. So these are very old tubes, and it's just a really nice chip. It's interesting information. They're like a quick reference. Now, for people designing these radios, this was in a radio design shop. Is that possible? Of course it's possible. Of course it's possible. The only thing what's down here now is the power cord, which is in perfect shape. Suspiciously good looking power cord here, not polarized. And we've got the 2 cap wires, plate cap or grid cap, and they have the two sizes. Excellent. And they're there. We got this little guy here. This is for some unusual tube, I imagine. Very good. Okay, I think I've looked it over enough now. What I can do is read this quick chart. Drink coffee, read this quick chart, and then we're going to give this guy a go and see if it works. The word is, when I bought it, yes, it works. Just before I went for coffee, I noticed this small piece of paper I had missed. E2 may not work. E2. So E2, we're talking about E2. Okay, well, if E2 is required, then we will try something else. Now I picked a tube at random. 6C4. Is it really a 6C4? It may not be. 6C4 is a very simple tube. Yeah, it looks like one. 6C4. The condition of this tube, I do not know. Just because it's in this box doesn't mean it's new. We don't know. Okay, we're going to find out. Now, I've read the instructions, but we will go through them together. They're quite simple. They're really very simple. Okay. Depress the off button and connect attachment plug to the power source. Off button, connect it to the power source. Okay. Not going to put the power on just quite yet. Oh, maybe I should. Let's find out. So I'm going to run the power to here through these light bulbs. Just one of them, in fact. So if there's something going on here, the light will come on very, very bright. If there's a short, that's what I mean. If there's a problem here, shouldn't do anything though. When I have this switch pushed, that's what I would think. Okay, 117 volts on the plug. Nothing happening. Good. I'm going to cut the power. Okay, so we just tested that off is off. That's all we've really done. Set controls A, B, C, D, and E to positions listed on roller chart. Okay, so we're going to go on the roller chart here. Oh, that's nice. Wow, a lot of these, they don't roll very well at all. That's really nice. So 6C, WT 6C. Now, sometimes they mark the end of the roll. They put it like that, but I don't see one here. So we'll find out. It's getting tight. Ah, we're at the end of the roll there. Stop! Stop! So it's got to be at the bottom of this side. That's the only problem with the roll charts here. 6A, B, a lot of 6Bs. 6C. 6C4. There we are. Special notes here. 6C4 must show short on 1-5. 6C4 plate short test. Depress 1 and 5 together. They're talking about these buttons here that go from 1 to 12. These are used for testing for a short circuit, even though it has all this malarkey written down here. We'll just keep following the instructions. So we're setting these according to the chart. 6C4. So 1, 3, 25, 11, 7. 1, 3, 25, 11, and 7. Not a 2. Is it just the 2? I think that's all this note said. E2 may not work. Funny that one setting here wouldn't work. I wonder what. It says may not work also. Like every good engineer and science sort of person, he's expressing doubt with everything. Okay, so I've done the ABCD. Let's just double check. That's a good idea. 1, 3, 25, 11, and 7. 1, 3, 25, 11, and 7. Then it's got a star and a 1. Well, what's that about? A star, kind of a star sort of thing, and a 1. These are levers, W, X, Y, and Z. This is maybe just a separator here on this chart. It's just supposed to match up with this line so your eye won't get lost. So we would do W1, W, oh yeah, W, that's right, W up here. So 1 would be set to W. So again, it's not on, 1 would be set to W like that. Okay, and the rest, I guess, are left on 0. There's nothing written here. Y is set to 5. No, it's just X. X is set to 0. Normal. I guess they leave it on normal. Blank must mean normal. And then the 5 and a 6 are set. Oh, this is a little tricky. So the 5 is set to Y and the 6 is set to Z. Filament connections. What's going on with the camera here? Filament. Why didn't you see that? 3 and 4. What's he talking about here? Filament. So I don't know what's going on with this. 3 filament. Well, I don't see anything on the machine that. See, this is what happens when you don't read the whole manual, just reading the quick manual. Maybe there's a. So just looking at other tubes here. So that's not always written there. 6C4, 3, 4. Isn't that what setting these are all about? Filament continuity. Filament continuity. Just keep reading the instructions here because return all levers to normal position using lever return mechanism. Release off button by depressing read meter. I'm not going to do it just yet. that's what they are asking. Next, rotate line adjustment until meter pointer lines up with line. Okay, so line, meter pointer lines up with line. Where? Oh, there it is. It's hidden right in there. It says weak and line. So just somewhere in this area, I guess, in the middle of that yellow patch. Okay, that's not surprising. Do the line adjust. Insert the tube, allow it to heat. Once it's heated, readjust the line adjustment control and throw the tube cond switch to tube position. It's already in the tube position. Should never said anything about that ahead of time, so I guess it's not critical where it is right up until that moment. Perform the short leakage test by depressing buttons 1 through 12. That's these. Every one of them. Wow, pain in the arse that is. Watching the neon light as each button is depressed. If the neon bulb glows as any one or more buttons are depressed, with the exception of the buttons listed under filament cont. Oh, okay, filament cont. That's what those are. So we're going to get a short on 3 and 4. Does it say don't push them or just ignore the results? Or those buttons listed, the tube should be discarded as defective. So it's going ahead and push them, but the light will come on 3 and 4. That's what it'll say. The light will come on 3 and 4. If short circuits have not been indicated, the neon glow has been obtained on those, and then it's a bad photocopy, on those listed under filament cont. So in other words, if the lights came on where they're supposed to and the light did not come on when it should not, then you're okay. Then throw those levers to the positions, and it's copied out here on the heading. So set these. So these have to be here. This has to be set. Line adjust. Tube goes in. Warms up. Line adjust. With all these down here. Short test. A couple of them should light up. 3 and 4 should light up. Over here. Then once you've got to that point, you've passed the short test. We then set these levers in accordance with the chart. And then we push the meter button and read the quality meter reading. The quality meter reading. So I'm pretty sure this is just an emissions tester, but pretty souped up emissions tester. Okay, going through the process now. We already have these set. We are supposed to apply the power by pushing this meter. This button. That seems weird to me. It says read meter. It also says tube test. Light has come on. So my dim bulb has responded. It's drawing. This is drawing some current. Very consistent current draw. The bulb is the same brightness. So we're running with only 88 volts on here right now. The meter has come up. If we push the line, so right now I don't think you push anything to do the line adjustment. It's automatically in the line adjustment situation. Release the off button by depressing the read meter button. Rotate line adjustment control until meter pointer lines up with line. Okay, so we got to give it the full Monty here of power. You can see the meter has come right up into the area. Do a little line adjustment. Yeah, beautiful. Insert the tube, allow it to heat. And of course, I do have other tube testers I can test this tube on. Tube testers I'm pretty sure are reliable. Come on out of there. This is your chance to shine, Mr. Tube. You've been in this box for what, 40 years? Come on out. feel the thrill of electricity pumping through your filament. It must go in here. It's heating up. And I don't remember actually setting a voltage for the heater, but I'll bet you it's this adjustment. Many. Oh, look! I didn't notice this over here. On this A, when you get around to this side, you get battery test, AC volts, DC mils, must be milliamps, and a resistance. So it becomes kind of just your basic voltmeter. I don't think it's a vacuum tube voltmeter by any means. I don't think there's any amplification or anything going on like that inside it. Okay, the tube should be warmed up. We do the line adjust. Well, it's still in the right spot because that's a small tube. It's not drawing a lot of current. So we're at 114 volts. That should be good enough, especially when you have this adjustment to compensate. Perform short leakage test by depressing buttons 1 through 12, watching the neon light as each is depressed. Here, have a better view of that neon light here. Okay, here we go. Well, that doesn't look good. Wait a minute. That's supposed to come on. That's supposed to come on. That's not supposed to be on. I don't believe this. That's off. That's off. Wait a minute. It's supposed to be 3 and 4. 3, 4, not 5. Oh, 6C4 must show short on 1 and 5. Okay, 1 and 5. Okay. Okay, there's another note here. Plate short test. Depress 1 and 5 together. And the light goes out. Okay, that's great. 6, 7. These lights will flash sometimes. That's just a charge dissipating in the tube. And number 12. That way you leave this button down. Does it not matter? Maybe it doesn't matter. It doesn't say anything. Does it say anything? It doesn't say anything down here. Do you just leave those buttons down? 6C4A has a 6CA4. No. Okay, never mind. Never mind. Do you just leave this down? How would you pop it up anyway? How would you pop this up? Push this? Yes, it popped up, and we got a little reading up there, but I don't want to pay attention to that. So pushing this will clear these out. Okay, now we set these levers. You have to push this to clear this out before you set these levers. Some tube testers setting levers under certain conditions are like having a tube in is bad news. This one said put the tube in. Okay, we'll set the levers. Lever number 1. This is a weird way of showing it. Lever number 1 is on W. Lever number... No, you don't say anything. Just don't say anything. Lever number 5. Ooh, look, you could read these numbers and think they're these levers. I could. I don't know about you, but I could. 5 is on Y. 5 is on Y. This is a slow tester. It takes a long time to set this up. 6 is on Z. That's it. So W, Y, 5, Z, 6. 6Z. Wow, right. It's easy to get this confused, I think. For me. But I think we're set. What do we do now? Depress the read meter button and observe the quality. Okay, what's the quality? Quality is good. Button quality is not so good. The quality is good. How did this get up high like that? I don't think it would make any difference. She's good. Okay, I think that's enough of a tour through this tube tester. You got an idea what I got here. Very interesting machine, no doubt about it. Made by a company that I think tried to live up to its name, Precision Apparatus. So I think they've done their best to make this a precise guy. Let me pull this out before I make a mistake, and maybe turn it off. Make another mistake. Return all that to nothingness. There we are. Okay, that's great. That's the Precision Apparatus Testmaster 1054 tube and set tester. Great. Next time I do a house call, I'll bring this. Hey, thanks a lot for watching. And I got another couple tube testers to check out down the road, but the next thing is the next radio. So tomorrow I start on the next radio. Thanks a lot for watching. See ya.